Okay, so as in the last video we have completed discussing about example number 1, which was all about the motion of a projection of a particle along the uniform circular path, which you can also say the connection between uniform circular motion and simple harmonic motion. Alright, so in today's video we are going to start the motion under elastic restoring force, or you can say Hooke's law. So which is the second example. What we are going to discuss today is we are going to discuss second example, which is motion under elastic restoring force. Right, or you can say Hooke's law. We are going to study here the mass spring system, right? What we are going to study today here, we are going to study the mass spring system in the Hooke's law. Now see, for understanding this mass spring system, we must make 3 figures so that everything must be crystal clear to everyone, right? For example, here I have a stand. Here I have stand 2 and here I have stand 3, right? This is step number 1. Here step number 2 and here step number 3. Step 1, step 2, step 3. Let's make the spring with a mass of body M. Okay, so for example, here I have a spring. With that spring we have a mass attached, so this is mass. Originally this mass is here, which means it is on its mean position. And what we have discussed about displacement in this case here, displacement would of course be 0 since this is mean position. So x, which represents displacement, is 0. Okay, second case, if we stretch this spring, where this would be at its extreme position, right? Here. And what it is, its extreme position. And where displacement would be equal to what? It would of course be equal to x naught, or you can say amplitude, since amplitude is the maximum displacement from mean to extreme position, right? The third case, when we have stretched this body, now this body will have some force. This body will gonna have a force which we're gonna call it as restoring force. What we're gonna call it? We're gonna call it as restoring force. Since this restoring force now restore the original position of a body, but what do you guys think? When it will restore, this body will gonna directly go to its mean position? Of course not. Now it will go somewhere here. So let's make the third step. This is third step, right? Now this body is here again to its extreme position. extreme position, where displacement is equal to what? Where displacement is equal to x naught. Okay, so we have now made here 3 steps. How you're gonna understand mass spring system is very easy, right? How it is easy concept, let us now understand. See, in step 1, for example, your mass is attached with a spring. Okay, this is step number 1, which means the body is on its mean position. We are not doing anything to the body, but now we are going to stretch the body. When we stretch the body, for example, this was its limit from where we can stretch till, right? So this is its extreme position. But now when we leave the body, now it will have some force which will be known as restoring force, which will gonna restore the body to its original position. But that we know that if we're gonna leave this body, it will not gonna go directly to the mean position. However, it will go here, since this is elastic spring, right? So now body is here again on its extreme position. So now we have understood this basic figure of the mass spring system. Now it would be very easy for us to understand the formulas which we're going to drive. Now see, elastic restoring force, elastic restoring force is directly proportional to the displacement from mean position. Let's understand this. It's a very important point for the mass spring system. The elastic restoring force, this restoring force is directly proportional to the displacement, to the negative displacement taken from the mean position. See, what would be the displacement here? This would be the displacement here, right? From its mean position to the extreme position, this is displacement. And displacement is always taken away from the mean position, right? Displacement is taken away from the mean position, and this force is acting to make this body go towards the mean position. Displacement is taken to away from the mean position. Force is making this body go towards the mean position, which means negative sign, right? So Fs, which is elastic restoring force, is directly proportional to the displacement, but negative displacement, since displacement is always taken away from the mean position, and this restoring force is making body go towards the mean position. Now see, if we remove this proportionality sign, we're gonna get a constant. So Fs is equal to minus kx. Now this is the formula for the elastic restoring force. Elastic restoring force. Right? Now see, this k is a constant. K is a constant called spring constant, or force constant. spring constant or force constant. And if you want to find this K, how you're going to find this K? K is equal to Fs. This minus x is multiplying with K here. When it will go there, it will be divided. So x negative, right? So this is how you're going to find the K, which is constant, known as spring constant or force constant. So in today's video, what we have done, we have understood the diagram of the mass spring system, and we have driven a basic formula for K, for finding the K, which is spring constant or force constant.